So what made you become an engineer? You might go into this into your presentation, but what made you become an engineer?
Well, part of it is, this is why I want to get to my presentation, is that it's in my DNA. So I'm a third generation engineer. So my grandfather originally was an apprentice engineer, an instrument engineer, back in the 20s and the 30s. He did his indenture apprenticeship, which took him to Leicester and back up to Liverpool during the Second World War. My father actually managed to get to grammar school, and he went to Liverpool University and studied physics originally, and then metallurgy, which metallurgy is materials engineering. I rebelled. I love sciences. I absolutely love science at school, maths, and I was very fortunate. Well, it depends on where you see it as fortunate. My primary education was experimental at the time in the 1970s, where children were allowed to choose what they wanted to study during the day. I'm dyslexic. I didn't actually learn to read until I was about 7. But I could do maths. And so I elected most days in J2 to do maths. More maths, more maths, more maths, more maths. So in Y2, I spent a lot of time doing maths. They had to put extra classes on for me for English, try and get me to read and write. I had a lot of one-to-one. I eventually cracked it and learned to read, and I read a phenomenal amount now. But writing is still my biggest challenge. I got to secondary school and absolutely loved chemistry. Thought it was brilliant as a subject. Experimenting, making things. I was one of the few people who could go in the labs and produce and follow an experiment. I ended up my sixth form going to work for the University of Sheffield during the summer holidays as a technician, designing laboratory experiments for the first year students and the second year students in chemistry at the University of Sheffield. And I applied to the University of Sheffield. Well, I applied to lots of universities to study chemistry, and in the end, I was given several offers, but I accepted at the University of Sheffield. Now, ironically, in my second year, I got to do the lab experiment that I had designed, which is just ironic, you know. But in my second year at my chemistry degree, previous year I'd worked for a refractories firm during the summer holidays and worked with engineers and scientists. And then the following summer I worked for somebody who was Nuclear Electric. Now, Nuclear Electric is now known as EDF. They were bought out by the French company. And they had an engineering simulation labs over in Wythenshawe on Timpson Road in Manchester. I spent my summer working with control and instrumentation engineers and chemists, and rather than mathematical modelling simulation and software, the boiler systems inside nuclear reactors, they actually had physical rigs, exact replicas of these rigs that are inside nuclear reactors. And we were heating them up using electricity and insulation. And the chemists were simulating the water chemistry that goes into the pipework. And we'd measure the chemistry that's coming out. So what we were trying to find out, if we've got this set of water chemistry going into the pipework, what was its impact on the metalwork inside the reactor, and how much corrosion was it causing, how much wear and tear it was causing, and then predicting back and then mathematically modelling up at what point would each pipe suddenly have to be switched off, because that's the problem. You can't go and repair pipework inside a nuclear reactor. You actually, all you can do is close valves and close that set of pipework. So a nuclear reactor is designed to last 25 years. And its primary is not the nuclear reactors the problem, it is the boiler system that's the problem, because it rusts and wears. So the reason for these simulation labs was to look at how could we extend the life of a boiler inside the nuclear reactor, because for every year we can have the nuclear reactor lasting longer than 25 years, it makes a profit, because the cost of designing, building, maintaining, running a nuclear reactor effectively never makes any money. But if you can run it beyond its lifespan of 25 years, because it's paid for itself over 25 years, you start making a profit. So it's actually quite important work that we were doing in Manchester. So I really enjoyed working with the engineers, and I was particularly doing some mathematical modelling for them to decide the optimisation of chemical dosing, because there were multiple variables, and I went away and programmed some computers to do what we needed to do, and they were impressed. So I ended up being a sponsored student. But I really enjoyed working with the engineers, in particular control and instrumentation engineers, and it was the first exposure to control engineering and instrumentation engineering. So I decided that year, finishing my final year of chemistry, that I was going to switch. I was going to become an engineer, despite my parents had originally suggested to me that I did chemical engineering. So I applied to Bradford University, and I was interviewed for a scholarship as well from the Wellcome Company, which was a huge pharmaceutical firm based actually in Dartford. So my links with Kent already had started. And I won the scholarship and ended up at Bradford University studying control engineering. What happened was the research projects, because part of your MSc you have to do a research project. So I had 2 semesters of taught classes in control and instrumentations, mathematics, which I love. The project that was relevant for me and my background with chemistry and the engineering was actually not in the UK. So it was a sugar plant, evaporation plant, based in Valladolid in Spain, with the Universidad de Valladolid under Professor Cesar Brada. So I went off to Spain for sunny 6 months. And it wasn't sunny when I arrived, it was -8, because I arrived in March, and I left in August when it was 45 degrees C, so from one extreme to the other. It was great fun. It was a long way from home. I was in I can't imagine you can think or imagine what it was like being in Spain in the early 90s. But Spain had been in a dictatorship, and had only come out of that dictatorship about 10 years, 12 years earlier. So in terms of country development, in comparison to the rest of Europe, the majority of homes didn't have a telephone. I mean a landline, not mobile, had no landline. Most homes did not have central heating. So you can imagine going into a flat with marble floors and it being -8 and no hot water. That was the norm. So it was such a contrast in some respects, going there and studying that. But some of the advantages of that was the engineering that had happened. So the sugar factory was designed all about managing their energy and utilising energy that was being generated in the factory to drive other parts of the factory, whereas in the UK, the attitude was energy is cheap, and we designed the plants to be controlled easily and things so they wouldn't recycle the engineering and the energy. So the things I was seeing in the early 90s are relevant to today, where we want to optimize and reuse as much energy so we don't waste it, so we don't cause greater carbon footprint and an impact on the environment. So engineers are very intuitive with working with the resources they've got. So when there's a driven problem and financial issues and environmental impact, we're more likely to be driven in finding working within that narrowed envelope. it just, for a control engineer, it can actually become a nightmare to control. So that was one of the challenges I was working in. And at the time I was working with artificial intelligence algorithms, and that's eventually took me, when I graduated, into the working environment, and I ended up working in artificial intelligence algorithms for supporting and supervising management of a distillation column in Castleford. So I got to work in AI 25, 26, 27 years ago, long before everybody else. Why is AI taken so long for NASA to now be more mainstream? So some of the reasons why the AI I was developing at the time wasn't actually adopted on the rigs is nothing to do with the AI, it was to do with the hardware. So the communication cables coming off the plant, sending instrumentation information. It take 10 minutes to send things, and a chemical plant can change its position and how it's operated within 10 seconds. So then we would, at that time, the hardware of means of comms was not capable of doing, transmitting the information we needed to transmit. So we moan about broadband, and I've got 50 meg broadband here, and it's not doing what I wanted it to do. Can you imagine what I think I was doing with 100 kbps back in the early 90s? Hence why we weren't able to transmit what we wanted to transmit and then process that data to back in real time. So it wasn't that the algorithms weren't capable of doing what we wanted them to do. We were just, the hardware wasn't there. Now the hardware is coming along. We can offer more of that artificial intelligence support system. I also at the time was working was asked to do some teaching at the University of Huddersfield as I had a staff member go off sick, and I loved it. I was teaching robotics to the apprentices engineers who were working for DB, David Brown. Really enjoyed it. I was teaching them automation. We were looking at cars, parts manufacturing, die casting. So I was teaching a lot of manufacturing engineering. Loved it. And so I got back into academia and did a PhD in process control, effluent treatment, again using some artificial intelligence algorithms for controlling the plant. I have my own plant, designed my own plant, built my own plant. And I've been an academic since 2000. I worked at Sheffield Hallam University, and then I'm now setting up a brand new engineering department down in Kent. I'm a very typical engineer in that I knew about engineering because my family were in engineering. So it's not only my dad's an engineer, materials engineer, my grandfather was an instrument control engineer. So I didn't know that's what he was until much later in my life when I was able to see what he'd been doing. My brother is a mechanical engineer, but actually agricultural engineering, and his final year project was actually a control engineering problem, which I helped him on. He works for Caterpillar and works in Dusseldorf. So there's a lot of engineering exposure. From the city I'm originally from, Sheffield, the heart of the steel industry of this country, the vernacular, the local vernacular, and the schools we went to, we got taught CDT. I got to work in metalwork labs, I got to work in woodworking labs. The vernacular that's built into our language is very engineering. So when we talk about making friends, we talk about forging friendships. So a lot of our phrases and comments are actually hidden and based in engineering. And part of that, what I'm talking about in my journey to engineering, was about what I was going to be presenting in Prezi. So what do I do now? Well, much of my day is managing the other engineers, exciting people like yourselves into inspiring you into engineering, designing and developing the current curriculum at Canterbury Christchurch University, because it's a brand new engineering course and there's lots of opportunities with that. and lots of challenges. So we've got a new building, new laboratories going in, we've got to buy equipment with COVID-19. That's providing a lot of challenges about what companies still exist, who are still manufacturing. We wanted to bring in an up-to-date curriculum. So we talk about Industry 4, which is about more automated manufacturing, and using that technology and using that data to support manufacturing. So there's some of the areas that I've worked in for the last 25, 30 years, which were very much blue sky at that time, and probably too advanced for the technology, is now mainstream. So we're bringing that into the curriculum. I get to work with some fantastic engineers who have spent the weekend and last week developing outreach activities with little engineering exercises that you can do at home. So you can learn some of the basic concepts behind engineering. My colleagues and I have been working at the request of Canterbury Hospital on a respiratory system, not for patients, actually for staff. I apologise about the telephone. There is somebody else who will answer that. Other activities we're involved in at the moment is working with other local businesses and looking at optimising their manufacturing systems, you know, whether that's going to be automated systems or whether that's going to be just looking at Lean Six Sigma approaches to make their business more agile and throughput through their businesses. Currently, we're learning for a lot of businesses with COVID. So in order to manufacture and socially distance, there's a lot we can learn from them at the moment, who businesses have gone back. We can utilise that learning to then support other businesses. So lots of opportunities at the moment. Feel free to ask any questions, because Prezi is definitely not loading.
Is it not loaded? Don't worry about it. I think you've kind of done quite a nice presentation there about, you know, how you grew up with engineering and how you came into engineering and your role now. And so thank you for sharing that with us. Then you mentioned kind of your family are all kind of engineers, or you've got engineering kind of in your blood, hasn't you?
Yeah.
Were you constantly building things when you were younger? Was that kind of ingrained in you?
So with my family actually originally being from Liverpool, my grandfather as a child was given one of the first Meccano sets. So Meccano is actually originally from Liverpool. So my grandfather had this huge quantity of Meccano, vast quantities of it. When my grandfather passed away, which was in the mid-70s, my brother inherited the set. My brother and I would spend hours playing with Meccano. We had proper clockwork, mechanical motors. We built cranes, all sorts of structures. It was great for fixing bikes when we were wanting to fix the bikes when we were older. We had tons of Lego. I spent hours playing with Lego. I'm also, I think I like things ordered. So this is one of the reasons why I like looking at manufacturing systems and how things can be improved, but I like things very structured. So you'd also find me with the Lego box and tidying it and coordinating it in colours, shapes and sizes that I still do. I'm not very good with a huge box of Lego all muddled up. I don't like it. My brother was the typical engineer in that he dismantled everything. I'd come home to find my lipsticks dismantled, because if I'd got a different shaped lipstick, he couldn't believe the mechanism would be the same. I knew it was. I'd already figured and worked it out. My brother would have to dismantle it to figure that one out. So we approached engineering from different perspectives. I like joining things up. So a lot of what I do now and still did there, I don't learn something in isolation. I take something I've learned and then start figuring it out to something else over here. That helps being a control engineer, because a control engineer has to understand every field of engineering, not to great depths, often sometimes very superficial, but we have to have a grasp and understanding of different things to be able to control something. So it makes it different in that respect.
I've got a question here on Facebook, Anne, saying you mentioned about working with AI. Do you feel like it's come a long way in the last few years?
I keep reflecting on this. I think we make steps forward and then we go backwards, and it's different challenges each time. I mean, the areas I was developing on was using expert systems, so absolutely encapsulating holistically the knowledge from across a team for running this distillation column, because the way the shifts work, communication flow was awful. So encapsulating that into a model and supporting then the operators running the plant, because they operate as a team and they worked in isolation, so they were missing half the information all the time. It's no different than developing some sim systems today. You're still very dependent on encapsulating that knowledge from human knowledge and insight, and that is extremely time consuming to get that information out of human beings, because it's very holistic and we're not very good at sometimes expressing ourselves. So some of the challenges we have today are exactly the same as they were. The difference is now hardware's caught up. We have different challenges like lack of broadband. I think time constraints, the speed of response, as you know, my presentation not working, is still a challenge, because we expect things much faster now than we even expected in the early 90s. The ethical issues of AI, that hasn't gone away. They're still, we need, reflect upon that. And some of those processes of what we're doing, is it appropriate? One of the positive sides is comparison to 25, 30 years ago, and some of that is to do with decolonising the curriculum, but also understanding the greater world and understanding things that are ingrained, that are not good, means some of the data sets we're working with are flawed. And we have that insight now, whereas 25, 30 years ago, we probably didn't. So that's, which does then mean some of the artificial intelligence we want to develop, we can't, because we've got flawed data sets at the moment. And until we've got more cleansed and appropriate data and people have changed, then we'll encapsulate information more appropriately. What do I mean by that? So the classic example with that is, believe it or not, mortgage systems have been using artificial intelligence for about 20 years. And they're based on historic data of who is likely to default on a mortgage. Unfortunately, town planning, where immigrant communities have moved in, limits job prospects, limits then earning financial power, which then puts people at greater risk of defaulting on a mortgage. So those data sets then say that particular social group will default on a mortgage, therefore they should, if they apply for a mortgage in the future of that from that social group, they should be denied a mortgage because they're more likely to default, which is unethical, because society's changed, how we are trying to make progress and provide opportunities of equality for everybody. Those decisions then by that computer are made on data sets that are historically biased and not necessarily the way the future's going forward.
Yeah, thank you very much, Anne. Next question we've got here is, do you prefer being an academic now to your previous roles?
I love teaching. I wouldn't have made the investment of going back to university and studying a PhD and it was considerably longer than the 3 years, because I had to design, build a rig. There's a lot of challenges of getting that rig working, and then developing the algorithms to control it and publish. That's a huge investment in time. And I love teaching. I love motivating people and getting people to understand what I'm trying to do, and interpret and go on to be engineers in industry. I love working with industry. And I'm too much of a magpie. So I like projects. I like lots of working on different things. If I was in industry in a set particular area, in a set subject area, I'd probably get pretty bored. It's my nature. The advantage of being an academic, I can move around fields. So, okay, the advantage of a control engineer is you get to work in all different areas of engineering. So, I've worked with mechanical engineers, automation engineers. I spent 10 years in the electrical engineering department in academia. And then I was given the aerospace engineering team to manage, and I never worked in aerospace engineering. I had to get my head around it. I do a lot now. I did a lot of projects with developing learning with aerospace engineers, even going to learn to fly a plane. Back now with mechanical engineers and materials engineering. I even got to teach my father's subject area. My previous employer and do now. I couldn't have done that. I don't think I would have had that opportunity for me in industry to have moved around in fields of engineering. I mean, now I'm working with building industry and construction industry and developing programs. So, yeah.
So I bet you've kind of impacted a lot of students' lives, and then have they gone to kind of have big careers then, Anne?
Oh, phenomenal. So for the best part of about 8-10 years at Sheffield Hallam University, I was responsible for computing network engineering. And I used to run a program of life post degree and bring in my students. And there's a bit of a competition with my students, because computer network engineering students are very much either they go into software development, or they go into networks, or they're very entrepreneurial and go on to run their own businesses. So to place it in context, there's a bit of a competition amongst my ex-students of what car they eventually have. So one of my ex-students has a Ferrari. We're all a bit partial to their sports cars. I have one ex-student who now runs a very, very successful cybersecurity business, who's probably more busy than he'd like to be. He runs a very successful business outside Cambridge. Yes, people who've gone on to be very senior engineers and directorship level in the likes of Rolls-Royce all over. One of the ex-students I've taught in electrical engineering was at director level of electronics firm who were making the replacement Hubble. Hubble telescope for going up into space. He's now moved to another firm and doing very well. So yes, they've all, quite a majority have gone on to, do very interesting work and projects and what they've done. And one of my ex-students works for McLaren, Formula One. So, he was an electrical engineer, working with mechanical engineers and supporting McLaren. So, yeah, I've even had students on placements at Red Bull in the year that Red Bull won the Formula One. So not even at graduate level, at placement, they've had great opportunities to go and do some exciting things. My husband wasn't impressed because I went down to Red Bull on the day Webber and Weber was there after they'd just won the championship. I was not popular.
Wow, that's incredible. I think that's amazing. And like you said, I bet you get free tickets to places as well, like you said there, to the Formula One at times.
I don't. My
Oh
students,
no. Yeah, yeah.
I've seen my students very burnt after being at competitions. No, I don't. I was there to see my students, so I didn't go and see Webber and Weber.
Oh right.
That's
I
important.
think you should request the one. You should request for tickets.
Maybe. But the difference is in the past, Jaguar Land Rover has invited me to Jaguar Land Rover to test drive their cars as a bit of a incentive so that I'd persuade students to apply to them. So I have been on their test track in an 80,000 Jag and driven it at nice speeds, as well as doing their 4x4 course, which is only open for testing the cars. So yeah, you do get some perks occasionally.
Yes, I was going to say some nice perks to the job there as well. Brilliant. Just another one. Obviously, you're working at home at the moment. So has COVID affected your work? Or are you able to kind of contact people online and everything, and contact students online?
So COVID, yes, has really changed how we're working. So I'm currently based in Sheffield, so I have a disparate life. I work in Canterbury, setting up the engineering department, and I live there in the week. Normally, I live in Sheffield at the weekend because my family's based up here. So I'm actually in Sheffield. Most of the team are in Canterbury. Some other members are elsewhere in London. We're meeting regularly via Teams. Actual fact, communication flow has drastically improved. Ironically, COVID has enabled us to communicate better through MS Teams. Without this technology, we couldn't be doing what we're doing. We're using Blackboard Collaborate and virtual learning environments to teach students up until the end of the semester, which has been able to support them. Some of the challenges we're having is working through how we're going to do laboratories for next year. So that's really our biggest challenge. Engineering equipment and engineering subjects is very practical, hands-on, so we need to develop processes so it's safe for everybody, staff and students. So that's going to impact on how we work. As in terms of industrial engagement, so normally I go out to businesses, the team goes out to businesses, looks at on how we can support them. Of course, we can't do that during COVID, so we've actually had a lot of Teams meetings with businesses, but actually they've proven more productive. So they've been able to talk through and show their challenges. Whereas in a meeting, we'd make notes. We don't Google during a physical meeting and start solving their problems. The team, because with all the team, and also we can't take suddenly 8 people on site to go and look at what they need. Whereas we've been doing industrial virtual visits, we've got 8 of the team then on Teams. And while some people are having a conversation, others are furiously Googling and figuring something out and start solving and bringing up CAD and start modelling things and start trying to solve the problems they've got. We couldn't do that in a face-to-face meeting. So some things are suddenly working much better for us, whereas some of the things are a bit more challenging.
Thank you for answering those questions there. And I think this one usually comes when I think it's quite a nice one to end on. So obviously we've got some young engineers listening today. Is there any advice you would give to these young engineers?
Keep chipping away, keep making stuff, keep being curious, keep asking why. Drive your parents nuts. Don't accept things at face value. Go and look, go and read. Find out for yourself. Do some experiments. Do things safely, but look at things. And if you learn something in a class, say mathematics, find out what's that maths relevance for and take it to somewhere else. Don't learn things in isolation. Think about how you can push yourself to knit things together and look at that curiosity. Engineering takes the science and applies it to solve problems. And you can only do that if you're curious and find things out. So read. I can't emphasize that enough. And somebody who's dyslexic who found reading such a challenge and still does, I read anything and everything, and I'm curious about anything and everything. So I'm always checking the facts, checking things, looking at experimental results, reading and finding out, knitting things together.
Yes, I just want to say a big thank you to you and for taking time up your day to do this. I know you're very, very busy. So thank you very much. I know your presentation didn't manage to work, but I think we worked around it and you worked around it very well by talking about everything. So thank you for that. And I hope you enjoyed it. I hope you enjoyed everyone that's sending in their questions and answering those questions there. So thank you to everyone for sending those in as well.
Thank you for joining us.
We've also got an online survey. I've put that in the chat if you could complete that after the interview as well. And I hope you've been inspired to take on the Leaders Award competition and start designing. So use our resources on our website at leadersaward.com to help you. And please join us for our upcoming interviews as well. Thank you for everyone joining today. Thank you, and to you again. Bye, everyone.
Take care.